وعليكم السلام ورحمة الله وبركاته.
عليكم السلام ورحمة الله وبركاته.
Good. All right. All right. Let's continue the discussion about chapter 9. Yes. Okay. And this is chapter 9. This is the last part of chapter 9. We'll do it today. We're going to talk about a theory which is called molecular orbital theory. Molecular orbital theory. What was the theory?
The screen, doctor.
What?
We do not see the screen.
Oh, just a second. Sorry. Yes. Okay, good. All right, good. What was the name of the theory that we just finished before this one? What was the name of the theory? What? You remember the previous theory? It's called what?
Valence
bond. That's it.
Valence bond theory.
Valence bond theory. It depends on what? What's the main word that we use there?
Hybridization.
Yes, I want you to memorize the name of the theory and then the most important word, which is hybridization. What's the meaning of hybridization?
Mixing orbitals.
Mixing. And that's why we got sp, sp2, sp3, sp3d, d1, and sp3, d2. Right? Good. Now I'm going to talk about another theory, which is called molecular orbital theory. This one has nothing to do with this one. And before I start, I want to mention two things. What's the meaning of paramagnetic? What's the meaning of paramagnetic? Paramagnetic, if you have orbital or more than one orbital in which you have one or more electron unpaired. In this orbital, what's the meaning of unpaired?
Only one electron.
Lone pair. I mean, not lone pair. Unpaired means one electron. One electron. What's the meaning of paired?
Two electrons.
Two electrons.
Two electrons.
Yes. Now, if I have an atom in which we have one orbital like this and have it like this, is this going to be paramagnetic or diamagnetic atom?
Paramagnetic.
Paramagnetic. If I have another atom like nitrogen, if I draw the structure of nitrogen, okay, like nitrogen, in which at the end we have, is this paramagnetic or diamagnetic?
Paramagnetic.
Let's try something like oxygen, in which we have the last orbital, the last p, we have is this paramagnetic or diamagnetic? Oxygen.
Paramagnetic.
Still paramagnetic. Why? Because there's one
orbital with one electron.
Very good. Last one. How about fluorine? The last orbital is like this in fluorine. Is this paramagnetic or diamagnetic? Fluorine.
The same. Paramagnetic.
So paramagnetic. Fantastic. Now, the other thing I want you to do, if we have orbitals like this mixed together, what type of mixing is this? What type of mixing is this?
Hybridization.
No, mixing.
Head
What
to
type of
head.
mixing? Head to head. If it's head to head, what does that mean? What's the name we use?
Sigma.
Sigma.
bond.
Sigma. Okay, sigma. Very good. So this is called, what's the other name for it other than head to head?
Side to side.
No, end to end. Both of this, I mean, not both of them, they are the same name. What type of bond we have? Sigma. Clear? Same thing with if you have p orbital like this and p orbital like this. What type of interaction between the p and the p?
Sigma.
Sigma. Why sigma? Because it is
Face to face.
Head.
Head to head, I mean.
or
Head to head.
head to head or end to end. How about if I have two p orbital like this? What type of interaction we have?
Bi. Because face to face.
Bi, and this is called, what's the name that we use for it?
Side.
Face to face or side.
Face to face or
Side to side.
side to side. Is this clear? Is this clear so far?
Yes.
Yes.
I just want to add one more thing before I go further. Let's assume that I'm going to take all this aside. Next, if I have two atoms, like for example, oxygen, and the other oxygen is like this. Where are the p orbitals? We have one like this. Where is the other one? Yes? One like this. Where is the third one?
In the middle.
No, perpendicular to the paper, to the page. Not in the middle, it's perpendicular, متعامدة مع الورقة. واضح?
Yes.
That's why we call this one P what? X. And this one we call it P
Y.
Y. And this one we call it P.
Z.
Exactly. Same thing with this high oxygen, with this oxygen, with the P, and this is the. Now, if these two atoms together, what type of interaction between this P and this P?
Sigma.
Sigma. What type of interaction between PY and PY?
Pi.
Pi. How about PZ and PZ?
By.
Pi. So we're going to make one sigma and two pi if there is interaction like this. Is this clear?
Can you repeat it, doctor?
I will repeat it one more time, no problem. Let me also take this again. If we have any atom like oxygen with oxygen, we have three orbitals, px, py, and pz, right? Same thing with this one, px, py, and pz. The px with the px, when they mix together, what type of interaction is this? It's head to head or end to end. That's why, what type of interaction? Sigma. Okay, the py with py, how are they going to interact?
High.
Pi. How about pz with pz?
High.
Pi. So we're going to make one sigma and two pi. Clear?
Okay. That means it's a triple bond or what?
No, 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 no. But interaction. We did not talk about how many bonds so far.
Okay.
It's like this. This is the theory. Okay, good. How about if we have S and S? What type of interaction we can have?
Sigma.
Only sigma. Can we have bi?
No.
You have to know. Now, O2, using the valence bond theory, this is the structure of O2. And you can see here, these two electrons are paired, these electrons are paired, these electrons are paired, paired, these two electrons are paired, these two electrons are paired. So all the electrons are what? Paired. Is it going to be diamagnetic or paramagnetic according to valence bond?
Diamagnetic.
It should be diamagnetic. Why?
All are paired.
All are paired. But it was discovered by experiment. See, this is the experiment. This is the oxygen liquid. This is the oxygen liquid coming down, and it goes to the magnet. It goes to the positive magnet. This means it is paramagnetic. So O2 was discovered to be, O2 was discovered to be paramagnetic. All right? And we will explain using molecular orbital theory why it is paramagnetic. By valence bond theory, it should be diamagnetic, which is wrong. So the valence bond could not explain why O2 is paramagnetic. I think it should be diamagnetic. Good. All right. Now, let's go to the molecular orbital theory. As I said just a while ago, the theory, this is the molecular orbital theory now, says the following. If two S orbital like this, S with S, how they mix? How do we mix? Sigma. Very good. The theory, this is the molecular orbital theory, says no. When they mix, they will make two orbitals. One of them is called sigma, and the other one is called sigma star. Okay, this is the S with the S. When they mix together, they will make two new orbitals. One of them is called sigma, which is the sigma, make the sigma bond, and the other one is called sigma star, which is shaped like this, but it's one orbital and like this. We can also draw them by, this is the, we know that hydrogen is 1s, the other hydrogen is 1s. When they mix together, according to molecular orbital theory, they'll make one sigma 1s and sigma 1s star. Okay? And so, you remember when I told you, give me the electronic structure for hydrogen. What are you going to say? Right?
Yes. Yes.
How about helium?
1s2.
1s2.
How about lithium?
1s2 to B1.
2s1.
2s1. How about
Yeah.
to be sure. Right?
Yeah.
Oxygen. So what are you doing here? What are you doing? What are these things?
Electronic structure.
Structure of what?
Electrons.
For what?
And the add.
For the atoms. For the atoms. Is this clear? Now,
Yes.
Now we will do the electronic structure for molecules, not for atoms, but for molecules, consisting of 2 atoms only. So we're going to do the electronic structure for molecules. If the 2 atoms is hydrogen and helium, then the structure will be, if I ask you what's the electronic structure for hydrogen and helium, you should say sigma 1s, sigma 1s star. Now, how many electrons we're going to put? If we have H2 molecule, so we're not talking about molecule now, not atom. H2 molecule, how many electrons do you have?
2.
2. How are you going to write the electronic structure for H2 molecule? Sigma 1s2, sigma 1s star 0. Is this clear? Now, if I have H2 plus, what will be the electronic structure?
Sigma 1s1.
Sigma 1s1, sigma 1s star
0.
what?
0.
0. Exactly. How about if I have H2 minus?
Sigma 1 is 2. Sigma star 1 is 1.
Exactly. Yes. How about if I have He2? Let's do it here. Sigma
Sigma 1s2. Sigma star Sigma 1s star 0.
no,
Oh, it's 2.
also 2. Exactly. Yes. Very good. So what is this sigma 1s and sigma 2 1 star? This is what?
Orbitals.
It is orbital, but it is the electronic structure for what?
The molecule.
Molecule. This is the electronic structure for atom. Don't forget this. Okay. Now, we call the one without star, we call it bonding orbital. Bonding orbital. And anything with star, the star, this means it is anti-bonding. Anti-bonding. Clear? Now,
Clear.
one more thing which is important, we have bond order. Bond order equal to number of electrons in bonding minus number of electrons in, what's the star?
Antibond.
Antibonding divide by 2. So what is the bond order for H2 molecule? This is H2 molecule. What's the bond order? Yes. How many electrons we have in bonding?
2.
How many in antibonding?
0.
0. What's the bond order?
1.
Exactly. Bond order equal to 1. What's the bond order here?
Half.
Half.
Exactly. What's the bond order here?
3/2.
No, wrong.
Half.
Also half. Why half?
2 minus 1 over 2.
2 minus 1 over 2, which is half. What's the bond order here?
0.
Yes, 0. Why?
Because 2 minus 2 equals 0.
Exactly. That is now the structure. If you have 2 atoms of hydrogen and helium, and you have 2 atoms together, if I ask you to write the electronic structure for these things, you should be able to write the electronic structure for H2 or H2 plus or H2 minus or He2, or I want you to write now one more thing. Can you write the electronic structure for He2 plus? Can you write the electronic structure?
There will be nothing.
Sigma what? No, He2 plus. Sigma what?
1 is 1.
Sigma 1 is
2.
No.
2. 1 is 2.
2. Always count how many valence electrons do you have? He2
Three.
plus how many electrons?
3. 3.
3. Why? Because each helium has 2. 2 helium has 4. If you take plus, it will be 3. We make it sigma 1 is 2, and then sigma
1 is 1. Star.
1 is
1 star 1. What's the bond order?
half.
Ah, exactly. Let me ask you a very simple question. Which one is having a stronger bond? H2 or H2 plus? Which one have a stronger bond? Yes?
Can you repeat, Doc?
Which one is a stronger bond? Which one is stronger?
H2.
Why?
Two minus 0 will be 1.
The bond order is what?
1.
What's the bond order? Bond order means number of bonds. What's the bond order for H2 plus?
Half.
So which one is stronger?
H2.
H2.
This is stronger, definitely. Stronger. Okay? Stronger than H2. How about which one is stronger? H2 plus or H2 minus?
The same.
Yes, they're almost the same. Is this clear?
Doctor, how is H1, H2, I mean, stronger?
Because what's the bond order in H2?
Isn't it supposed to be sigma 1 is 1 and then sigma star 1 is 1 again?
That's no, sigma 1 is 2 and sigma 1 is 0.
Oh, okay. So it has
2 minus 0
higher
over
number. Okay.
with 1. Clear?
Clear. Thank you, Doctor.
Okay, the other question is, of course, the stronger the bond, the shorter the bond, right? Again, يعني كل ما صارت القوة أقوى كل ما صارت أقصى. واضح؟ Which one is shorter?
H2.
Is it
H2.
H2 or
H2.
H2 plus?
H2 because it's strong.
H2.
H2 is shorter. Is this clear? So you should be able to understand this. Don't forget, we want to do it for bond order. Always, I want you to, whenever I ask you about electronic structure, I'll take all of this away now.
Even for oxygen, doctor, we have to know how.
No. This is only for which atom?
Hydrogen.
Now, this is the electronic structure. This is the pin. What's the electronic structure of H2 or He2 or H2 plus and or H2 minus? What's the electronic structure for these molecules? Look here, two molecules consisting of only hydrogen and helium. What's the electronic structure?
Sigma 1s2.
Sigma 1s. No, don't put in numbers now. Sigma 1s, sigma,
Star 1s.
Star.
and then you find the valence electrons and then start putting them. Is this clear?
Yeah, but doctor, why do we always repeat 1s, 1s? Why don't we go to 2s?
Oh, this is for because we're talking about hydrogen and helium. There is only one S in them.
Okay.
This structure is only for which atom?
Hydrogen, helium.
Only. Is this clear? Any
Yes.
question? I want you to memorize this structure, which is very easy. Isn't it easy?
Yes.
And keep in mind, what are you going to put the numbers there? What's this number?
Valence electrons.
Number of electrons available, which is 1 or 2 or 3 or whatever. Okay? And if you put 0, this means nothing. It's empty. It's okay. Like this one, sigma 1s2, sigma 1s star. What should I write? Because there is nothing here. 0. Clear? And don't forget to find the bond order. How to find the bond order?
Sigma 1s.
No, what's the bond order?
Oh,
Electrons,
it's going to be 1.
electron in bonding minus electron in
Anti-1.
anti-bonding divided by 2. Clear?
Yes.
Good. Now we are done with hydrogen and helium only. We are now going to move to other elements, which is, look at this one. If we have only, we are going to do electronic structure of 2 atoms. Okay, 2 atoms. If we have lithium, lithium or boron or carbon or N or anything with mixed together, like N with C, or 2 atoms. What else? C with O, or C, B with F, or B with O. All of this we're going to have together, and we have different structure for O with O or F with F, or O with F. If you have only O and F, we're going to use structure A. If we have NC or CO or BF or BO, we're going to use structure B. And we're going to find the electronic structure for the atoms, 2 atoms. Always we need 2 atoms. I want to rewrite this I will rewrite it up there. I will take this away. Don't forget, we want to write the electronic structure. I will write the name, same name. Now, I will use the same letter A and B just for information. The structure A, how am I going to rewrite it so that I'm not going to give you this, and I want you to in the exam to be able to write it sigma 2s. And what's after sigma 2s? Sigma 2s star. What else? What after that?
Start with 2b.
Sigma 2p, and then by 2p. By 2b is actually 2 orbitals, but I'm going to write it by 2b, and you should know that 2p is 2 orbitals. And then by star 2p, and then sigma star 2p. And the structure B, I want you to sit down and memorize this one. It will be sigma 2s, sigma 2s star, and then sigma 2p, sorry. And after that, by 2p, and then sigma 2p, and then by star 2p, and then sigma star 2p. What's the difference between A and B?
The place of by 2b and sigma 2b.
These two are upside down. This one, this become here, and this become here, right? That's the only difference. Is this clear? Good. Now, I want you to understand very well that these are the electronic structure, whether it's A or B. If I give you now any atom, and of course, how many atoms I'm going to give you? This is for how many atoms?
2.
2 atoms only, whether they're the same or not the same. Let's try to draw the electronic structure of carbon. C2. What's the electronic structure of C2? You have to find how many valence electrons do we have.
8.
How? 8. Right. Because it's 4 plus 4. Okay? Where are we going to put these 8 electrons? In the structure. First, which structure are we going to use, A or B?
B.
B.
B. Because it's carbon with carbon. Clear? So we have 8 electrons. Where are we going to put them? 1, 2, 3, 4, 5, 6, 7, 8. That's it. Clear? So I want you to write the electronic structure, like here. What are you going to write? Help me.
Sigma 2s2.
Sigma 2s2, yes.
Sigma 2s star.
Sigma.
So 2s star, what? 2. And then, yes,
2p.
By 2b.
5.
2.
No,
By to be 4.
By 2b 4.
4. See, there are 4. 2 and 2. Good. Now, what's the bond order?
Two.
Why?
Because 4 plus 2 equals 6 minus 2 over 2.
So this is bonding, and this is bonding, so we have 6, and this is anti-bonding, so it's minus 2 divided by 2, which is equal to 2, exactly. Is this paramagnetic or diamagnetic?
Diamagnetic.
Fantastic. Is this clear? Good. Now, let's do it very quickly for O2, quickly. How many valence electrons do we have?
12.
12. Don't forget this. Now, which structure we're going to use, A or B?
A.
A. Why? Because it's O with O. Very good. So write the structure very quickly. Okay, we can put them. We have 12 electrons. Let's put them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's write the structure quickly. Sigma,
Sigma 2s2.
yes.
Sigma star 2s2.
Sigma star 2s2, yes.
By
No, no.
Sigma 2p.
Sigma 2p2, and then
Then by 2b4.
4, exactly, and then
By 2b star 2.
2, fantastic, super. Okay, what's the bond order?
2. Take
8
8 minus 4.
minus 4 divided by
2.
2, which is equal to 2. Is this paramagnetic or diamagnetic?
Paramagnetic.
Param.
Why para?
There are 2 lone electrons.
Because there's 2 unpaired electron.
Good, excellent. Now, if I use the molecule C or O2 plus, O2 plus, what will be the total number of electrons?
11.
11, exactly. Okay. What will be the structure very quickly? Sigma 2s 2, sigma 2s star 2, sorry. Yes, help me. Sigma 2p 2, sigma by 2p 4, and then by
2p1.
1, exactly. Okay, what's the bond order?
8 minus 3 over 2.
It's equal to what?
2.5.
So which one is stronger bond, O2 plus or O2?
O2 plus.
O2 plus is a stronger bond than O2. Is O2 plus paramagnetic or diamagnetic?
Param.
Paramagnetic.
You don't have to think. If the number is odd, then it's paramagnetic without even thinking. Clear? Very
Yes.
good. Let's do it for O2 minus. What's the bond order for O2 minus? To be 8 minus yes.
-5.
Yes, it is -5. Exactly. Exactly. By what?
By 2 equals 1.5.
Yes. Very quickly, let's do it for O2, 2 minus.
Minus 6.
8 minus 6 divided by 2, which is equal to 1.
41.
Good. How about, let's one more time, O2, 2 plus.
Minus 2.
8 minus
2.
2 divided by 2, which is equal to 3. Do you know how to make the electronic structure for molecules now?
Yes, a little bit.
It's easy.
Not easy, but it will be
Not
challenging.
easy.
Okay, let's try, for example, Cn minus. Write the electronic structure for Cn minus. First, you have to find number of electrons. How many electrons do you have?
10.
Exactly 10, because it's 4 plus 5 plus 1 electron from here, which is 10. What's it? Write the electronic structure quickly.
Pi
Sigma
equals
2
Sigma 2s 2, sigma 2s
star 2
2, and then
by 2b
yes, by which structure are we going to use, A or B?
b
B.
Yes. Okay, and then sigma by 2p what?
4
4, and then sigma 2p
2
2, and then no need. If I write pi star 2p, what number should I put here?
0
0.
0, and sigma 2p star, what's the number? 0. What's the bond order?
0 equal 3
Yes.
Which is 8
minus 2
divided by 2 is equal to 3. Excellent. Is this paramagnetic or diamagnetic?
diamagnetic.
Yes, because everything is paired. Are you able to do this? That's what I want you to know in this part of this chapter. Is this possible?
Shall.
Yes. Inshallah.
Oh, good. So let's do it for this one. O2 minus, what's the, using molecular orbital theory, determine whether is, first, I will ask you even more. O2 minus. I want you to write the electronic structure. Can you write that O2 minus structure quickly?
sigma
Sigma
2s2.
2 is 2
2s2. Then
sigma star 2 is 2
sigma 2s star 2, and then
sigma 2b 2
sigma 2p 2, and then
by 2b 4
4, and then
3.
3. Yes.
yes, thank you, 3. Actually, that's what you just told me. Can you see it?
Yes.
Now, what is the bond order?
8 minus 5 over 2
1.5.
1.5
1.5. Is it paramagnetic or diamagnetic?
Parama.
paramagnetic.
Paramagnetic. Why? How many ampere electron do we have?
It's odd.
1
Let me ask you another question. Let's say that I have O2 only, not this one. I will do it one more time for O2. What's the bond order? Quickly.
2
2. Why? Because I'm losing 1 electron from here. So it will be, the bond order is 2. Very good. I mean, What's the valence for O2 minus? Valence. 13.
13.
How about for O2? It's 12. So I'm going to lose electron from the last orbital, which is
By
2p
2p star.
it will be 2 instead of 3 here only. So what will be the bond order? 2 exactly. Is this paramagnetic or diamagnetic?
Para.
Paramagnetic. Why?
It will have 2 lone pairs.
Because in the bi,
Yes.
this bi is 2 orbitals, not 1. And we have 2, each one will be in a room like this. Is this clear? How easy?
That's easy.
Great. Okay. Okay, that's it. We want to stop here and we finish chapter 9 in here. That's all what I want you. I want you using the molecular orbital theory to write the electronic structure. Let's have one last example. I have 2 minutes to go before, or 3 minutes to go. Give me any other, you give me any items.
Floor.
How about can we have this bond according to the molecular orbital theory? NF. Can we make this molecule?
Isn't it a noble gas?
Ne is a noble gas. So
Doesn't react.
what's the valence of neon?
8.
8.
Eight.
What's the valence for fluorine?
7.
0.
What's the total?
15.
15.
15. Which structure are you going to use, A or B?
A.
D.
Excellent. Okay, write the structure then.
Sigma 2 is 2. Sigma 2 is 2 star.
Yes.
By 2p4.
No. Sigma 2p first.
Right.
And then by to be what?
4.
4. Okay, and then
By 2b star.
4.
4.
4, yes. And then
Sigma
Sigma.
2 star 1.
sigma what?
2p star 1.
Exactly, yes. So is this paramagnetic or diamagnetic?
Paramagnetic.
Para, since there is one here. Okay, what's the bond order? Eight.
Half.
8 minus what?
7.
5
7.
bar 2, which is equal to what?
Half.
Is this easy?
Doctor,
Yes.
isn't the A structure for O and F only?
O and F and Ne, neon. And if there is neon also.
And doctor,
Notice, if the F with B, we're going to use also a structure B. Or the O with B, we're going to structure B. Only if O2 or F2 or OF or NEF or NEO or things like that, we're going to use this one. Clear?
Yes.
I hope so.
is
But
it
this,
possible C with F?
نعم.
Is it possible C with F?
Yeah, C, right, yes. B. A or B?
B.
B.
Anything that consists of carbon or nitrogen or boron with anything else, it will be in B. Clear? Any question?
Yeah.
Very good. With this, we finish chapter 9. And let me open the attendance for you. And you can take the attendance and you can leave right away.